This question is taken from Math Problems in Real-World Context, published by Marshall Cavendish Education. This serves as a guide for question 12, Road Safety. So after going through the information given by the question, we need to show that triangles EWX and CYX are similar. With the information given, I'll now check for the ratios. I see that the ratio of the length EW to CY is 4:1. The length of the ratio WX over YX is also 4:1. We have also been given that angles EWX is equal to angle CYX, which is 90 degrees. So this has been given to us. Therefore, the two triangles will be similar if we use the SAS similarity test. So I'll write that down. Now part B wants us to find the distance of CE. Since I have two right angle triangles, I'll be able to find the lengths of CX and EX separately before adding them together to find the distance CE. So I'll leave you to find the value for distance CE. We'll go on to the next question. The surveillance camera is positioned at a certain height. The greatest angle of elevation of the surveillance camera when viewed from any point along DE is 18 degrees. It is given that a car plate is 30 cm from the ground. Mr. Tan claims that the angle of depression of a car plate at E from the surveillance camera is less than 4 degrees. Is he correct? We need to justify our answer with calculations. Now, if you go back to look at the diagram, and I want the angle of depression of a car plate at E from the surveillance camera, I'll be looking at CE as the distance between the two. And at C, that is where my surveillance is. So the camera is positioned at a certain height. So I'm just going to let the height of the camera be CH. And then at E, the car plate is 30 cm from the ground. And Mr. Tan claims that the angle of elevation of a car plate at E from the surveillance camera is less than 4 degrees. So if I were to draw that in, the angle of depression of it from the camera is 4 degrees. So we need to check whether his claim is correct. Now I'm going to fill in a few things. So CE, the distance CE, is what I have found from part B. Then now I need to actually find the height of the surveillance camera in order for me to verify Mr. Tan's claim. So I need to find the height from the question that has been given. The greatest angle of elevation of the surveillance camera when viewed from any point along DE is 18. Now, if we go back to the diagram, where would the greatest angle of elevation be if my surveillance camera is at point C? It will have to be the shortest distance from C to the line DE, which will make it this point here. Let's call this point y prime. It's an extension from y. Okay, so it's another 4 meters away. So I'm going to try and find the height of the surveillance camera given cy prime is 5 meters. So CH, and I have y prime here that is 5 meters. The claim was that the greatest angle of elevation would be 18. This will help me to find the height of CH. So the first step that I will do is to find CH, the height of the surveillance camera. I'll use my Trigo ratio. Tangent 18 will be CH over 5. So with the height of CH, I can now find and verify if Mr. Tan's claim is correct, that the angle of depression is less than 4 degrees. Less than. So I need to get my answer from part B. The length of CE from part B would be 15.811. This is corrected to 5 SF. And I have the height of CH. And I will need to minus away the 30 cm because the the car plate is 30 cm from the ground. So if I want to find this angle here, okay, I'm going to let this angle be theta first. So I will use my trigonometry ratio again. So find theta. Tangent of theta is actually CH minus 30 cm. So CH now is currently in meters. So I will need to take CH minus 30 cm. I need to change it to meters. So I will get 0.3 meters over 15.811 meters. Now I have to use the 5 SF here because this is an intermediate working. Now the answer that we get for theta is actually 4.8 degrees corrected to 1 decimal place. This is more than the 4 degree that Mr. Tan claimed is the angle of depression of the car plate at E from the surveillance camera. Therefore, Mr. Tan is not correct.